Hey guys, welcome to today's tutorial. We'll be looking at the equation of a circle and a semicircle and pretty much in its basic form. Okay, I won't be doing too much with it, just showing you what it is and how we can use it. Okay, so the very basic form we're going to look at to start off with, which I don't particularly like starting off with, but I will in this case because I know that's how most people are taught. We are taught the form of x squared plus y squared equals r squared. Now that is the basic form of a circle with the following properties: that the center of my circle in that case is at the origin 0 0, and it has a radius of r units. Okay, so what do I mean by that? Well, let's have a look at examples. Let's say, for example, it's x squared plus y squared equals 9. Okay, because it's x squared plus y squared, I automatically know that the center of my circle is at the origin 0 0. I also know that the radius of my circle is 3, because 3 squared makes 9. Alright, what would you do with that? Well, then what we'll generally do, okay, we'd simply draw an axis, making sure, well, we don't need to have the origin at 0 0, okay, which is there. But we also know that my radius is 3 units, so it goes 3 places to the right, so 1, 2, 3. It goes three places up, 2, 3, 3 places to the left, 2, 3, and 3 places down. Now, the one important thing to note when you are sketching a circle, it doesn't need to be dead accurate. Okay, that's the number one thing. It doesn't have to be accurate, but the most important thing, I guess, which is the number one thing, is that the x and y axes here, their values have to be going up by the same width. Now, we know that normal graphs, the x-axis have to be consistent, but it doesn't have to be the same width as the y's. In this case, it would, because we know that a circle has an equal radius. So if I sketch my radius that way, can you imagine if I used like a much smaller or a bit much bigger one? Let's say that was 1, 2, that was up here, but I still kept the 3 there. You'd find that what's going to happen, it's going to come to a bit of an ellipse sort of shape. So let's just make sure when you are drawing a graph of your circle that the distance from here and here is exactly the same for scale. Okay, so that's a very basic equation of a circle. Now, you might think, well, then why don't I usually like starting off with that? Well, there is another formula for a circle. It is a bit slightly more complicated formula, but I think it is much more important. It is x minus h all squared plus y minus k all squared equals r squared. Now, it looks a little bit similar in the form that it's got a y and an x in it, it's got some squares, and it's got r squared. Now, what's different about this one? Well, this one has a center of h comma k, where h and k are normal numbers, and the radius is the same, it's still r units. Okay, so it just means that you might have a circle where the center might not be at that 0 0, but it might be, let's say, 1 2, might be up here somewhere. Okay, and let's say we've got a radius of 1, like that, for example. Okay, it's going to look like that, so it moves. So the center HK, okay, is the center of that circle. This center, if I said that was going to be 1 2, the formula would look like this: x minus 1 all squared plus y minus 2 all squared is equal to 1 squared, which is 1. So that would be the formula for that circle that I just drew there. So what is different about this formula as opposed to the other one that we just looked at? Well, it's not different, it's actually the same formula. If you think about it theoretically, if I have a center of 0 0 and a radius of r, because that's what we looked at the first formula, well, let's put the 0 0 where the h and k are. We get x minus 0 squared plus y minus 0 squared equals r squared. Well, x minus 0 is just x, y minus 0 is just y, and r squared, and what you'll then notice, that is the formula that we just looked at. So it is actually the same formula, it's just that that second formula, that first one we looked at, was always at the center of 0 0. Still both important to notice, because obviously it's much quicker to know that if it is at 0 0, then the formula is just x squared plus y squared. But it doesn't take that much longer to do x minus 0 squared. Okay, So very brief introduction of a center of a circle and the radius using those two formulas. So what's the third thing I want to look at? Well, I want to look at the semicircle. Now the semicircle we know is half of a circle. We know that the formula when we look at the center of 0, 0, that is my formula, okay? X squared plus y squared equals r squared. So when I'm looking at half of a circle, we want to make just y the subject. We want to have y is equal to. Now you don't really need to know this process. You just need to know what the formulas look like. So I'm going to get rid of the x squared and put it over here and make r squared minus x squared. I then want to square root both sides, okay, so I can get y is equal to. So I get the square root of r squared minus x squared. The only issue is, you know, when you square root something, you have both a positive and a negative value, because square root of 4 could be 2 or could be minus 2. So these are my two values, or my two formulas, which makes a bit of sense too, I guess, in terms of if I look at a circle, let's put a circle on here at center 0, 0, it creates two semicircles. We have a positive semicircle, which is there, which would be the y is equal to the positive square root of r squared minus x squared. And then we have a negative one, which I'll do in yellow, which is the one underneath there, that one underneath there, which would be the y is equal to negative square root of r squared minus x squared. Okay, so it's just slightly a little bit different, but the r squared is in the center there, which is the first unit, I guess. So you might have something that looks like this: y is equal to the square root of 16 minus x squared, all right, which would then lead you to believe, well, we know that because it's at x squared and y squared, we know that the center is at 0, 0. We know that that's the radius, which means 4. So we've got negative 4 to positive 4 and positive 4 up here. So that's my semicircle in there. Okay, so look, I've spoken briefly about the equations of all of those. The very last thing I just want to mention is just domain and range, and go back and have a look at the other ones there with my domain and range. If I look at the first one here, we know that domain, because I'm often asked to mention domain and range. So if I look at the domain of this one, we know that domain is all the x values. You'll notice here that the x values only go between minus 3 and 3. So x is greater than or equal to minus 3 and less than or equal to 3. And my range is my y values, which again is, in this case, x is greater than or equal to negative 3, less than or equal to 3, because it goes up between those two values there. Okay, obviously it can't be up here, because if I go anywhere along there on my y equals, there's no actual value there. So my domain and range of those two. If I look at the second one here, which we looked at, this formula here, okay, my domain for this one, or my x values, what goes between these values here, which is 0 and 2, okay, had a radius of 1. So x is greater than or equal to 0, less than or equal to 2. If I now look at my range values, my possible y values, okay, well, if that's 2, then that's going to be 1, isn't it? Okay, so it's greater than 1 and less than 3. So y is greater than or equal to 1, less than or equal to 3. Okay, cool. Now, just noticing there, that range should have been a y there. My apologies. My apologies indeed. And the very last one, which is sometimes a more challenging one, which is the semicircle, sorry. Okay, if we look at this semicircle one here, then we can say my domain, so my x values, well, it's not actually much harder, is it? X is greater than or equal to negative 4, less than or equal to 4. You can see it goes between those two values. My range, however, this time, y will be greater than or equal to 0, less than or equal to 4, because it goes between those two values. Okay, so just a very brief introduction once again on circles and semicircles and looking at domain and range. Hope it made sense, hope it was useful. Let me know if you need some help.